my name is Siti Mazharni and I would like to share about the project overview. At first, the purpose of development in detached office buildings situated on Lot 5147 at Pesara Muntadahari, Puncak Alam Selangor, commissioned by a multinational construction company. The building architecture concept has already been designed. The project team, or our project team, tasked transforming this perimetry design into a comprehensive building information modeling representation focused solely on the architectural concept and scope. This is also include the delivery of 3D design, 3D model, detailed drawing, schedule and supporting data using the BIM methodology. Our objective, first, to develop a 3D BIM model from the existing 2D architecture plan. Second, propose 2 architectural design improvement to enhance the original layout. Third, compile comprehensive project deliverable, including drawing, schedule, and accommodation detail. Demonstrate the benefit of BIM in project visualization and the coordination. Our key feature is, first, 3D architectural BIM model, which is developed using industry standard software, adhering to a green level of development, which is LOD. Second is design alternative, that to improve version of the original layout to enhance space use, aesthetic and sustainability. Third one is modeling schedule, which is inclusive of material and feature schedule directly to connect to the BIM element for clarity and automation. Last but not least, data-rich documentation, which is reorganized and delivered with embed component properties and metadata. For the project timeline, we have actually around 15 weeks, which is week 1 to week 3. We review the original 2D architectural plan and coordination that we did. For week 4 to week 7, we're using BIM model to develop a refinement of architectural design. For week 8 to week 10, we prepare of drawing and schedule, also make a feasibility studies. For week 11 to week 30, we compile of a full report and quality check. For the week last, which is 14 to 50 week, we have a final presentation and project submission, which is this week. So for the scope of work, we actually have a 5 scope of work, which is first, initial design review. We assess and interpret the provide 2D architectural plan. We also coordinate with our team members, understand the project requirement and align on objective. The second one is model development and design alternative, which is we construct the core 3D BIM architectural model based on 2D drawings. Third is documentation and feasibility, which is we extract architectural drawing, floor plan, section, elevation, generate material and fixture schedule, and performing the feasibility analysis comparing the original and propose the alternative. Last but not least, we have a report compilation and also quality assurance, which is we assemble all the project deliverable, model documentation schedule, and analysis into a comprehensive final report. We conduct internal review to ensure the accuracy and clarity. Last is final presentation and submit. We prepare and deliver a 50-minute group presentation that show the BIM model, design rationale, and key project. Submit the finalized report and the model.
Modeling detail. Development of architectural building information modeling BIM. Model for the detached office building was carried out in several structure phases, utilizing industry standard practice and software to ensure accuracy, efficiency, and data richness. First, software and tool use. Primary BIM software, Autodesk Revit was used for modeling due to its robust architectural features and extensive BIM capabilities. Then, supporting tools. AutoCAD is for reviewing the original 2D drawing, and Microsoft Excel for extracting and organizing schedule. Second is a level of development called LOD. So the model was constructed to LOD 300, which include accurate representation of geometry, dimension, and orientation, and then embed data on material, features, and key building component. Then detailed plan, elevation, and section generate from the model. And the last, third, standard and protocol. The modeling process adhere to Malaysia BIM standard and guideline. Then naming conversation and layering system for clarity and collaboration. Then best practice for file management and interoperability. BIM modeling technical progress. So they have 6 phases. So the first is setup and preparation. Then define project parameter including label, grid, and base level to establish spatial reference. Then setup share coordinate, project unit, and naming conversation for consistency. Second phase is architectural model development. Apply proper wall type, material layering, and parametric constraint for precision and ease of update. Include building component like stair, railing, and shielding system using Revit component tool. Phase 3 is integration of BIM data. Ensure that all architectural elements were LOD 300 compliant to support documentation and analysis. Then use worksheet and link it file to organize model content and enable collaborating editing. Fourth phase is alternative design development. So evaluate design improvement in terms of spatial efficiency, daylight access, and circulation logic. And then create a distance view and shape to illustrate and compare the design option clearly. Phase 5 is schedule and quantity extraction. Generate automate schedule for wall, door, window, material, and features directly from the model, and then verify quantities and cross-check them against the model geometry for accuracy. And then export the quantities and schedule into Excel for future analysis and feasibility evaluation. And the last is phase 6 is quality accuracy and reviewing. So conduct multi-model audit to identify and resolve duplicate element, model clashes, and inconsistency. So second is reviewing model accuracy in element with the initial architectural drawing and intent functionality. And third is finalize the model structure and layout for presentation and reporting purpose.
Modeling process. The first step is project setup. Create the new model, click browse for template file window, and then click program data. Go to Autodesk Revit 2024, go to template English and select default metric RT. Save as file final project. The next step is construct elevation line. Open the East window view on the project browser. There are two levels shown, level 1 at 0mm and then level 2 at 4000mm as default elevation for template. Edit height level from 4000mm to 3500 and copy the elevation line from the ground level to level 4 with height level 3500mm. And the third step is construct grid line. Open level 1 window, use the level filling element to show project base, point and survey point and height. On architecture tab, click on grid, click on the project base point and drag it to create vertical grid line and name it as A. Use the copy function to construct 6 vertical line and 4 horizontal grid at specified measurement. And the last step is build the 3D model. This includes constructing floor, wall, roof, and other critical components that lays the groundwork for the architectural model. With the help of Revit user, friendly tools, architects and designers can be precisely capture the geometric and spatial configuration of each element to reflect the intended design accurately. Here is the 3D model of our purpose office building, developed using Autodesk Revit. The structure is a 3-story detached office building with a modern curved design. Starting from the bottom, we have the ground level, which the main entrance and essential public area such as lobby and sitting areas. Next, on the level 2 and level 3, we have an open office space and private office space and shares amenities designed to support collaborative and productive work environment. Each level is designed with large glass panel to maximize natural lighting and promote a comfortable working atmosphere. Ground floor plan. The light purple level is an office lobby, the green level is a stair area, the blue level is a men's toilet, and the pink level is a women's toilet. First floor plan. As you can see, we have first floor lobby area. We also have a meeting room, men's toilet, open area 1, open area 2, stairs, store 1, women's toilet, and working area for the workers to do their job. For the second floor plan, we have a second floor lobby, men's toilet, open area 3, area stairs, store 2, women's toilet, and a working area. Elevation plan, we have 4 elevation view, which is front elevation plan that show our front building, that's the main entrance. We have right elevation plan that show our office area. For the back elevation plan, we have only shown the toilet window, and left elevation plan shown all the working area and open area for the level 1 and level 2.
Data and information. First of all, starting off with the structured data inside the BIM model, there are 8 types of elements that involved in this project, starting off with the building type, location, access, number of floors, wall type, roof type, window type, and also the door type. Each of these elements are included with the data type and also the example of values that are included in this project. For example, the access is calculated or either level property, which is included with the 14.4 meter. Moving to the number of floors, each of the floors will be level counted, and also the building is 3-story. As we all are aware from the building's model, the wall is a family or either type parameters, and it is a cast in situ concrete. As we move into the next data information, which will be the architectural element. As we all are aware of, architectural elements is one of the essential parts that might shape up this building's design, structure, and also appearance. The types of architectural elements that involved in this project are the curtain wall, brick wall, the roofing, floor, staircase, and other elements such as the meeting table, the flower pot, and also the curved sofa. For your information, the curtain wall will be located at the entrance of the building. The brick wall with a thickness of 156 mm with the plaster both sides. For the roof was constructed with the measurement of 10 degrees. So, the third part that I want to explain is the feasibility study analysis. There will be 2 design models, which the first one will be conventional, the second one will be enhanced sustainability. So, what are the differences? Well, the first model, the construction will be mostly based on brick masonry with plaster both sides. For the toilet layout, there will be 2 categories for each toilet, which will be for male and female. As for the space use, it's very enclosed rooms, which will be limited open space for the second floor only. So what are the advantages? First of all, it will be cost effective. Second, it's a simple construction. Third, it's an easy material resourcing. You can find it anywhere, easily. So there will be a disadvantage. So what are they? It will be poor insulation, mainly because of the higher cooling cost. Second, limited natural lighting and ventilation, which might cause our bill, and also will reduce user comfort because of the poor lighting. If you see in the other end, the design model for the facade, they have used curtain wall system, which will be glass and also aluminium frame. For the structure, the building mostly constructed by cast in situ concrete, and for the interior part, it will be better finishing and also expanded open area compared to the first model. As I said, for the first one, the toilet area will be same as the model 1. So, what are the advantages for this model 2? There will be improved natural lighting and ventilation, better thermal regulation, enhanced energy efficiency, and also higher spatial comfort, which will be an important part in this model. One of the most considerations that we have to put in our mind is the higher initial cost compared to the first model, which will be higher compared to the first model. So, lastly, as in for the summary, our project is located on number PT 5147 Persiaran Moqtadari, Puncak Alam, Selangor, is basically developed for a multinational construction company. The first design follows a more traditional method, which will be using brick walls with plaster both sides. Each of the floors includes separate male and female toilets, as I already explained in the previous slide. For the second design, it improves on the first by incorporating model features the enhanced both functionality and also sustainability. The design also includes more furniture to support different working needs and expands the open area to the second floor. Overall, from this project, the second design is a smarter, future-ready, and also a big solution that better aligns with the client's goals and also expectations in the future. That's all from us. Thank you.